and then I'll help you and answer questions, and that's when it's going to click for you, for most of you, okay? So hang on with me as best you can until that happens. But you have to attempt the problems and the practice in order to make any headway in this unit. And if you're not doing that, then you're going to be behind faster than you know it, okay? All right, so if you recognize this is very similar problem that we did in the warm-up, except we're doing it in a different way. Notice the instructions say to find the functions using identities instead of the reference triangle, okay? So it's still important to follow this step first. We need to know what quadrant we're in so that we can appropriately assign signs to certain functions. So if secant is negative, that means cosine is negative, right? This is just review stuff. So cosine is negative. It says tangent is greater than 0, so that indicates that tangent is positive. So it can't be this one because cosine's negative. It can't be this one because cosine's negative. Tangent's negative up here, so it's got to be in quadrant 3. Okay. So let's just kind of put that in our pocket for a minute. Okay, so we are going to do this using only reciprocal quotient and Pythagorean identities. So don't need none of that O over A business. Well, the good news is the first one I know pretty quick. I can use a reciprocal identity to find the cosine of u, and that would be just negative 2 over 3, because I know I can flip secant over to get cosine. And as a side note, this right here, we've only seen it really as x and theta so far, but it can be any letter, any Greek letter. You'll see it look like all of these things eventually. It can be x, it can be u, it can be t, it can be phi, it can be theta, it can be, beta, it can be alpha, whatever. All of these are just x. All these are just x's that are fancy, okay? They have different names. All right, continuing on. Okay, well, now I'm kind of stuck because, I can't get tangent without sine and cosine. So I need to use something that connects sine and cosine together. Previously, we had no such relationship, but now we do because of the Pythagorean identity that states that the sine squared of u plus the cosine squared u is equal to 1. Remember that when you see this notation in your brain, you should be thinking this. In practice, this is what this means. Okay? These are equivalent, but this is the notation we will use. But in practice, this is what it means. Okay? Okay, well, I know what cosine u is, so I'm just going to go put that in there, okay? So let's say I have, I'm going to swap back to my other notation because I like it better. Plus, well, what's the cosine of u? Well, that's just negative 2/3, right? Notice all I did was took the cosine of u and plugged it into this formula that I had. I just plugged it right in there. It's just a number. So what is this number? Let's look. The sine squared of u. So what's negative 2/3 squared? It's 4 over 9 or something. Double checking. 2/3 squared. Yeah, 4. Okay. Okay, so this is looking a lot better already. This is just 4 over 9, equals 1. Well, guess what? I can solve for sine squared of u just like I can solve for x, okay? So watch me do that. I'm going to subtract 4 over 9 from both sides, and I'm going to have sine squared of u is equal to, Okay. So if I have x squared equals 5 over 9, how do I get x by itself? I take the square root. Do the same thing here. I'm going to eliminate the square by taking the square root. So this will actually be the sine of u is equal to the square root of 5 over the square root of 9. which is actually just the square root of 5 over 3. Your calculator will tell you that. Okay? So now I have sine. But some very important piece, when we take the square root, we actually get 2 solutions, right? Plus or minus. So which one is correct? I have to choose. Is it the positive one or the negative one? Well, that's where this comes in handy. Let's go back up here. In the third quadrant, is sine positive or negative? It's negative, so we're going to choose the negative root. So I'm going to choose the negative one. I'm going to choose the negative one because that's the sign I'm looking for. Choose the negative one. So the sine of u is actually negative root 5 over 3. All right, let's see what I got so far and what I need. I got cosine, I got secant, I've got sine. I can get cosecant pretty easily, right? So let's do that one right here. So this would be cosecant. We're going to use a reciprocal identity. We're just going to flip it. This would be negative 3 over root 5. You can use your calculator to rationalize the denominator, and you're just going to get negative 3 root 5 over 5. Okay. So there's cosecant. There's sine. I've got cosine up here. And the problem gave me secant. Okay, well now how can I find, which other 2 do I need? Yeah. So look, I've already done these right here. The tangent of u using a quotient identity, we can just divide sine by cosine. So here's the sine divided by the cosine, which gives me the tangent. And then I can use a reciprocal identity to get the cotangent. All right, I'll just flip tangent over and I'll get this. So notice how we used a combination of the quotient identities, the reciprocal identities, and the new one, the Pythagorean identities. I'm going to do another one of these, by the way. Good? Oh, wait a second. So grab your hexagon sheet again. We're going to add some more identities to it, but you need to make a special note that you cannot get these off of the hexagon. You got to memorize these. So I'm going to give you a minute to write them all down, okay?
Will these be on the question board too?
Yes. And then I'm going to give you a second to write them down, then I'm going to walk you through them. These are called the even-odd identities, as you can see. You do not have to write this down. I'm just going to show you something to try to help you connect why we call them even-odd. And notice the negatives are intentionally left off for cosine and secant. They're having more fun than we are. And this will be up there too if you want to go back and double check your notes later. Okay, so let's talk about this for a second. This is just me conceptually connecting these ideas. This is something that you already kind of intuitively know from the last, 2 years of studying algebra, you remember when we were talking about polynomials earlier in the year and we said that that's an even degree polynomial? An x cubed is an odd degree polynomial? Okay, well, if I take a negative number and square it, I just get a positive number, right? Is this true? Look at it. Like if I take negative 2 squared, that's just equal to 2 squared, right? You get 4 in both cases. The negative just drops out. Yeah? Okay. Well, an odd function, you actually just get the negative here. So let's say I take negative 1 and cube it. I just get negative 1, right? Notice the negative sticks around. In odd functions, the negative sticks around. In even functions, it's eliminated. Okay. So sine and cosecant, if you take the sine of a negative angle, you get a negative value. Same thing with tangent and cotangent. Tangent of a negative angle is a negative ratio, right? But cosine and secant are like the squares. If you take the cosine of a negative angle, you get a positive ratio. The negative drops, okay? Okay. We're going to use that in a problem. So let me do another problem for you. This will be my last example for you before you do some on your own. This thing hates me today. I'm not sure why. Whatever. All right. Let's do example number 2. Let me find it. All right. Example number 2. So it's going to be very similar to what we just did with just an extra step. So say given that cosine of negative x is equal to 3 over 4 and tangent of negative x is equal to negative root 7 over 3. I don't know why I wrote root 3 over 3. It's root 7 over 3. Find the other functions. Okay. So all of our identities that we learned, the first section that I taught you about identities, all of those are for positive angles, right? If you're looking at your trig hexagon, other than in the odd even ones, everything is positive, right? Everything's positive. So if you're going to use those identities, what you're working with needs to also be positive. So let's make that happen, okay? So the cosine of negative x using an even odd identity is just equivalent to the cosine of x, right? So the cosine of x is also 3 over 4. I used an even odd identity in the fact that cosine is even to drop that negative. It's just gone. Like it literally is just poof. That's just something you know, okay? That's just something you know happens. Now, on the other hand, tangent is odd. So if I make this positive, the identity says that that's equivalent to negative tangent of positive x. So I'm good here. This looks like all the stuff in my identities. This one's not good yet. It's got this negative hanging out front. How can I eliminate it? Multiply all the way through by -1 or divide out that negative and we'll just end up with tangent of x is actually equal to positive root 7 over 3. And so now I've got some information I can work with. I can use the identities now because they match, right? They all have positive angle values. This is positive, and this is now positive. Whereas when we started, it was not, and so we couldn't apply those identities. Let's figure out what quadrant. All students take calculus. Cosine is positive. See, the cosine of x is a positive number. The tangent of x is a positive number. See, tangent x is now positive because we applied all this stuff up here. So where is the only place that cosine and tangent are positive? Well, in quadrant 1. So that's where we are. We'll keep that in our pocket just in case we need it later, okay? All right, so now at this point, after I've gotten everything looking right, I'm exactly where I was in the first example. So I can easily find secant using a reciprocal identity. That's 4 over 3. can easily find cotangent using a reciprocal identity of tangent. So that's 3 over root 7. Let me scoop this up a little bit for you. So far, do you see how I got secant and cotangent? Yeah, you just flipped them over. So let's rationalize the denominator real quick. That'll be 3 root 7 over 7. Your calculator will do that for you if you're not doing it in your head. So let's take stock of what we've got, because at some point you're going to lose track in your calculations. You're going to be like, I don't even know what to do next. What you're trying to achieve is getting all 6. Well, I currently have 4. I have no sine or cosecant. So my next step is going to be to use the only thing I know of that's going to really connect those two. And that is the first Pythagorean identity. Sine squared x plus cosine squared x equals 1. Because I know what cosine is. I have something there. So let's go plug the value we have for cosine into our identity. So this will become sine squared x plus 3 over 4 squared equals 1. Okay, so what's 3 over 4 squared? That's 9 over 16. So this is really plus 9 over 16 equals 1. Well, how can I isolate and solve for sine squared? Well, we're going to subtract 9 over 16 from both sides. So this will then become sine squared x equals, 1 minus 9 over 16. So what is that? I think it's 7 over 16 or something. It is, thank you. So I got 7 over 16. Am I looking for sine squared? No, I'm looking for plain old sine. How do I undo a square? Take the square root. So we'll end up with sine of x is equal to plus or minus root 7 over 4. Because what I end up doing here is I just take the square root of 7 and the square root of 16.
Where'd you get 7 and 16?
So 1, if I subtract 9 over 16 from both sides, I'll get 7 over 16. So that's how that happened. And then I just take the square root of the top and bottom because I'm taking the square root of both sides to eliminate the square. So I've got an issue here. I need to make a decision. Is sine positive or negative in the context of the problem? It's positive. So I'm going to choose the positive one, right? So this, I'm going to take sine to just be root 7 over 4. And then guess what? I've got cosecant, right? Cosecant x can be obtained with a reciprocal identity. We flip it over. That's 4 over root 7. Rationalize your denominator in your calculator and you'll have this. And now you've got all 6 by the most long, drawn-out process ever. So you remember what I said at the beginning? That you would be like, oh God, why? And you may be feeling like that right now. Let's work on a few and it'll start to make more sense. Okay, so you have a couple of assignments for today. I actually abbreviated your assignment. I was going to make you do like 14 problems and now you only have to do like 7 of these. So if you look under Fundamental Identities Day 1, you'll see that there's a Google Doc. See right here? You will do the odds on this page. And then you have a delta math, which is helping you recall how to factor trinomials, factor difference of squares, add rational functions. Because tomorrow, instead of doing those with x, we're going to do it with sine, cosine, tangent. So it's important. We're going to factor with those functions. So we got to remember how to do it plain old x first. So those are the 2 things. Okay. Odds on the fundamental identity Google Doc and the delta math. Do the fundamental identities first so I can help you with them. Don't skip to the delta math, okay? Do that after. Let me help you with the identities first. Just the odds. And then I'll talk to you a little later about journal entries and blah, 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 blah that are not due tomorrow. Those are not due tomorrow. So